Okay, this Zoom session is being brought to you by the Fractal Bullseye Water. All right, so now we're going to do inverse trig for other functions: inverse cotangent, inverse secant, and inverse cosecant. Well, cosecant is 1 over a sine, a secant is 1 over a cosine, and a cotangent is 1 over a tangent. So the arc cotangent of x is the arc tangent of 1 over x, and the arc secant of x is the arc cosine, get out of here, cat, of 1 over x, and the arc cosecant of x is the arc sine of 1 over x. Okay, excuse me. I have a cat here demanding treats. Hey, cat, here. Get out of here. Well, we're going to be talking also about trig of arc trig. For example, cosine and tangent of arc sine, or sine and tangent of arc cosine, or sine of cosine of arc tangent. However, I still have a cat demanding treats. Excuse me. Excuse me, folks. Okay, okay, come on, come on. Get out of here, cat. Well, I think he'll just be staying here and annoy me. The reason why he's being more needy, I think, is because I just set my daughter off on the airplane to Portland. Well, she'll be starting up her new life with an apartment and a job and a partner. And I feel simultaneously sad at her leaving me and joyous that she's become an independent adult. These feelings. We proceed. Here, cosine and tangent of arc sine. Here's the idea. We draw this right triangle with whose and I'll put arc sine here of x. So the sine of this angle is x. That's opposite over hypotenuse. So put an x opposite and a 1 hypotenuse. And then by Pythagoras, the third side will be root 1 minus x squared. Then cosine of that will be adjacent over hypotenuse. This over root 1 minus x squared over 1, or in other words, just root 1 minus x squared. The tangent of this angle, arc sine, will be opposite over adjacent, x over root 1 minus x squared. Now for sine and tangent of arc cosine, here's a right triangle with an angle of arc cosine here. So adjacent over hypotenuse is x. So put an x here and a 1 here. And Pythagoras teaches us that this third side will be root 1 minus x squared. So sine is opposite over hypotenuse, root 1 minus x squared. Tangent of arc cosine is opposite over adjacent, root 1 minus x squared divided by x. Now we have sine and cosine of arc tangent. Okay, so draw a right triangle where this angle is arc tangent. So opposite over adjacent is x, so put an x opposite and a 1 adjacent. And then by Pythagoras, the third side will be root of 1 plus x squared. Plus, not minus, as it was these other two. And then sine of arc tangent is opposite over hypotenuse, x over root 1 minus x squared. Cosine of arc tangent is adjacent over hypotenuse, 1 over root 1 minus x squared. So some examples. What's the cosine of arc sine root 2 over 2? Okay, we draw a triangle whose sine, here's the arc sine root 2 over 2. So you put a root 2 opposite and a 2 on the hypotenuse. Then Pythagoras teaches us this third side is root 2. And so cosine is adjacent over hypotenuse, root 2 divided by 2. Tangent of arc cosine of negative root 3 over 2. Okay, a negative is coming up here, so they're making things deliberately difficult. Okay, fine. So we'll draw a triangle in the plane, no longer just an obtuse and acute triangle, where the x value is minus root 3, and the distance out r is 2. So we have minus root 3 here, 2 here, up 1 here by Pythagoras, and we have a 30, 60, 90 triangle. Well, this is 30 degrees, so this will be 150 degrees, but whatever. So tangent is y over x, 1 over negative root 3, so negative 1 over root 3, aka minus root 3 over 3, to rationalize the denominator. Here, cosecant of arc tangent 1 is what? Okay, here's a triangle. This angle is arc tangent 1, so sides 1 and 1, third side root 2. Cosecant is hypotenuse over opposite. That's cosecant, hypotenuse over opposite. So root 2 over 1, therefore root 2. Okay, here's one similar to number 28. Cosine of arcsine root 3 over 5. I think in the problem set it's cosine of arcsine is somewhat different. All right, so we draw a triangle. This angle is to be arcsine of root 3 over 5, so we put a root 3 opposite, a 5 on the hypotenuse. And then the third side, well, square root of c squared minus a squared, root of 5 squared minus root 3 squared. And after a bit of calculation, that's root 22. So root 22, root 3, and hypotenuse 5. The cosine is adjacent over hypotenuse, therefore root 22 over 5, like that. Now, okay, cosine of arctan u, well, that's actually, I did that up at the top of the page there. Here's an angle, arctangent u, so opposite is u, adjacent is 1, third side is root of u squared plus 1. Cosine is 1 over hypotenuse, 1 over root of u squared plus 1. Or let's try tangent of arcsine u. What's that? Angle is arcsine u, therefore opposite over hypotenuse is u. So here's a u and here's a 1. The third side by Pythagoras is root of 1 minus u squared. Tangent is opposite over adjacent, therefore u over 1 minus u squared. Now, sine of arcsecant of u. What's that? Well, okay, an arcsecant is the arccosine of a reciprocal. So we draw a triangle with here this angle will be the arcsecant of u, aka arccosine of 1 over u. So adjacent over hypotenuse is 1 over u, so we put a 1 here and a u here along the hypotenuse, along the diagonal. This third side by Pythagoras is root of 1 minus u squared. Sine of that is opposite over hypotenuse, therefore root 1 minus u squared divided by u. Here's cosine of arccosecant of u, and that'd be cosine of arcsine of 1 over u. So here's the arcsine of 1 over u. So opposite is 1, hypotenuse is u, third side is root 1 minus u squared, cosine is adjacent over hypotenuse, root 1 minus u squared over u, which I notice is exactly the same as that. So it seems we have co-function things happening here. Okay, that looks good. Let's call this